Good morning, grade 12 students. In this session, we're going to continue with our revision sheet number 1, talking about genetics, solving some of the official exams exercises related to genetics. And here we move to the third question. Third question, they said hemophilia A is a genetic disease that is due to abnormality of the blood coagulation factor, factor number 8. This factor is the expression of a gene located on the non-homologous segment of the chromosome X, meaning that it is sex-linked. هيدا أول step. It's located on the non-homologous segment or non-homologous region or non-homologous part of chromosome X. We designate by H the allele responsible for the disease. هو قال لي إنه الallele H small is for the disease and N capital it's for the normal. يعني هون عم بيقول لي النورمال هو dominant and the allele for the disease it's recessive وأعطاني السيمبلز تبعولهم. So I have to follow these symbols. ففي أنا بعد شوي استعمل allele of the disease استعملها for example D or استعملها A small. لا, it's not the case وما في استعمل هيك because it's given. So I have to follow the given and I have to use the symbols in the given. Document 1 reveals the pedigree of a family that expresses this disease. Untitled disease, this pedigree, I have to use it in document 1. This document 1 shows the pedigree family members where some of these members they are hemophilic and they are designated here by black. So number 5 and number 8 they are affected. Woman 6 is pregnant and she asked for prenatal diagnosis for her fetus. فتعمل له تشخيص ما قبل الولادة للفيتس تبعولها. فتعرف إذا الفيتس عنده الأفكتد هيموفيليا ولا ما عنده الهيموفيليا. So they want this. First step, let's together indicate the genotypes of persons 6 and 7 and justify the choice. We have to justify our answer. أنا ما هعمل بس 6 و 7. I'm going to do 1, 2, 3, 4, 5, 6, 7 حتى 8, 9 and 10. Okay? So first of all, عم بقول لي هو allele of the disease is found on the chromosome X. So هيدي female عندها X. خلينا أول step نعرف شو عندهم. هيدا عندها X هيدا عندها Y. هون عندي X و X. هون عندي X و Y. مبينة مثل Y. خلينا نكبرها شوي بس. So these two X's. And here we have X and X. And number 7 عنده X وعنده Y. And this one عنده X Y. This female عندها XX. And this male عنده X وعنده Y. Let's start step by step. First of all, already we know that the allele responsible for the disease is recessive with respect to the normal dominant allele. So the female, it has 2 X chromosomes. So in order to be affected, it should hold or should express 2 X's holding the allele H in order to be affected. So here, and this one, female 1, it's normal. So هذه female 1, she's normal, so obligatory عندها allele N. And the second allele will be either XH or it can be XN. But she gave birth to affected individual number 5. So هيدا individual number 5 أكيد حيكون عنده XH. So it should be inherited from the mother. Here, the father obligatory يكون X and Y. ليش? Because if he had XHY, sorry, is عنده XHY, so this person will be affected. حيكون affected لأنه عنده بس X واحدة and the allele of the disease is represented in the non-homologous region of X. So إذا عنده XHY, this person will be affected. That's who we normal. So obligatory it will be X and Y. كرمال هيك, I said that this female should be obligatory. Obligatory, it should be what? It should be XM, XH. Moving to individual 3. 3. Let's move to Rama. Rama, what do you think? What is the genotype of the individual 3? First of all, normal or affected, ya Rama? Rama, can you hear me? Yes, Rama, you can speak. I think you had a problem in your mic. So let's move to Selena. What do you think, Selena? This person is normal or affected? Three. Individually three. Normal or affected?
Normal.
Normal. First of all, the female, it has XX. So it's normal. So obligatory, it has which allele is as you normal?
N.
Allele N. Very good. And the second allele, it will be what? XN or XNXH?
XNXH.
Justify your answer, please.
Because they gave birth to an affected child 8.
A. So this individual should inherit what? XH,
XH
one
from the mother.
from one of the parents, but sure should inherit it from the mother. So it will be XN, XH. Very good. While individual force Selena هو normal. So obligatory شو حيكون؟
XN.
X and Y. Very good. So X and Y. Moving forward, individual 5. محمد, individual 5 هو أكيد affected.
Yes,
So أكيد حيكون عنده أي genotype حيكون عنده X H
XXY.
Y. كرمال هيك قلنا نحن هيدي الانديفيدوال 1 حيكون عندها اكس اتش، هي تعطي الاكس اتش ما في ياخذها من الفاذر. طيب individuals 6 and 7. يلا genotype.
Uh,
justification
XN,
أكيد.
XN or XN, XH.
XN XH for XN XN or XN XH for what? Female 6.
6, yes.
6. So XN XN or XN
XH.
XH. Why? Justify.
ما she's normal
Is
يعني
normal.
she possess allele N.
So allele N is obligatory موجود. The second allele
Yes,
can be either XN, it's can be or XH.
or XH.
Okay, great. So XN XN or XN XH. The second one 7
X and Y.
X and Y مستحيل يكون XHY. إذا كان XHY it will be affected. Okay? Moving to individual 8. Individual 8, yes, yes, Samar. Individual 8, normal or affected?
8.
8, normal,
Affected.
affected. So, and the allele of the disease is found in the non-homologous region of X. So, the genotype, it should be what? XNY or XHY?
XHY.
XHY, very good. Type individual 9,
Normal.
normal. So, it can be what? هي female عندها two X's. يعني شو الجينوتايب تبعولها؟
XNXH.
Okay, this is the first possibility. Or it can be what?
XNN.
XN, XN, very good. So it has two possibilities, either XN, XN or XN, XH. While individual 10 is normal and it possesses only one X chromosome, so obligatory هتكون X and Y. So here everything is clear related to the genotype. أكيد بس يقول لي indicate بدي أعمل بس يقول لي justify بدي أشرح له إياها. I have to justify. هلا هو شو طالب بس؟ طالب بس only for person 6 and 7. But we did for the whole pedigree. أنت على draft paper always in the exam you have to do so. انت دايما على draft paper ارسم البedigree اذا بدك على draft or in the exam you can use the question sheet, you can use it as a draft using a pencil اكتب عليها in order to determine this. Also if you wanted to discuss the chromosomal localization, if it's on the XY, XY or autosomal, also do so in order to determine the localization. Do it on the pedigree. Part B, they should that show biological reasoning that this pedigree does not permit a sure diagnosis concerning the fetus. Fetus هو مين؟ هو ابنه لل6 وال7. طب ابنه لل6 وال7 اللي نورمال. but الفيميل ممكن تكون XN XH or ممكن تكون XN XN. So من بيو for sure is going to inherit the Y إذا كان boy. إذا كان boy. Before we start with the boy قبل ما أحكي about boy هي نحكي إذا كان female. إذا كان female ممكن ياخد اكس ان من امه واكس ان من بيه. Or maybe it will be xn xh. So both cases, إذا كان male إذا كان female sorry, both cases, both possibilities إذا كان أخذ XN من أمه وXN من بيه or XH من أمه XN from the father, so both cases will be normal لأنه عنده الأليل N اللي هو dominant اللي حياخده من الfather. But the problem is if this fetus was a male. إذا كان male, this is the big problem here. The problem is this individual is a male. Why? Because there's a male, sure, he will inherit the Y from the father. If arrow X, this will be either X and Y or it will be XHY, and here it will be affected. So this pedigree doesn't allow the sure diagnosis. Why? Because the fetus, it can be either male or female. If it's a female, it's 100% normal. But as a male, it can be normal or it can be affected. So here, let's determine the genetic risk for this child to be affected. How can we determine the genetic risk? First of all, genetic risk for this child to be affected, if to be an affected female, the risk is approximately zero, null, no chance for it to be affected. Since خلينا نرجع نكتب الجينوتايبس هون عشان كانت شوي معجوقة. So here عندي either XN or it can be XN XH. XN XH. While the male obligatory هو XNY. So it's obligatory here. So determine the genetic risk for this child to be hemophilic. First of all, to be hemophilic girl, the chance is, or the risk is null, is zero. No chance to be individual to be affected. No chance for this. Or it can be affected male. Why? Affected to be an affected male, first of all, the female should be heterozygous. So to be heterozygous, it can't be homozygous. مستحيل. إذا هي homozygous, no way. يعني هيدي no way to be homozygous. يكون عندها ولد affected. Why? Because if it's homozygous, it will inherit XN. So XN, sure, it's going to be normal. But if it's heterozygous, XNXH, so it can inherit XH. So the probability to be heterozygous is 1 over 2. And the probability to inherit XH is 1 over 2. And the probability to inherit to be an affected girl, an affected male, it's 1 over 2. So it will be like this. So here the pedigree, you can solve it step by step like this. It will be the probability for the mother to be heterozygous, it's 1 over 2. and and if she was heterozygous, the probability تعطيني XH كمان هي 1 over 2, and the probability to be a boy هي 1 over 2. So 1 over 2 times 1 over 2 times 1 over 2, it will be 1 over 8. Or you can solve it in another way. You can say the probability for the mother to be heterozygous is 1 over 2, and the probability for the children to be affected is 1 over 4. So it will be 1 over 4 times 1 over 2. But I prefer to use this. This will help you to understand more and more. So the probability or the risk is going to be 1 over 4 times 1 over 4 times 1 over 2. Moving forward, to clarify the diagnostic problem of hemophilia in the fetus, two tests were done. The first test, it was the karyotype of document 2. For the karyotype, what does this karyotype reveal? This karyotype reveals that this is a male. ليش male؟ لأنه عنده XY as sex chromosomes. So XY as sex chromosomes. So here, if you have XY as sex chromosomes, so here it's a male. فهي البروبلم هي يكون male. إذا كان female سهل كتير القصة. إذا كان female هيكون normal 100%. بس لأنه female لأنه male, so هون هي البروبلم. هو male حيكون affected. So this pedigree didn't solve any problem. لو فرجتنا إنه هو female, yes it did. Why? Because if it's a female, 100% it will be normal, and there is no problem with this. The second test is the analysis of the DNA of the chromosome X. The DNA of the mother, the fetus, and the sick person 8 are subjected to restriction enzymes. The obtained DNA fragments, they are separated by gel electrophoresis and they are hybridized by a probe. Because we cannot use an antigenic probe to distinguish the hemophilia allele from the normal one that codes for factor 8, we use probe ST14 that can mark a polymorphic zone more than one, very close to this gene. This zone, sorry, it has 10 alleles, but we have only two of these, they are present in this family. We have allele 3 and allele 5. هنستعمل أي individuals. هنستعمل individual mother والفيتس والsick person 8. هنستعمل sick person 8 in order to know which allele is going to code for the disease. That's why they use the individual 8 and mother 6 and the fetus. First of all, this one, it's found on one X. It has only one X chromosome. One individual 6, it has two X chromosomes. So pay attention to this. First of all, this is shown in document 2. For sure, this is going to be here, allele 3, and this one is going to be here. It goes down, I don't know why. This allele 3 it should be here, and the fetus, allele, person 8, sorry, it's going to be here. So person 8 has only one tick band where and the allele 5. So this is the one that correspond for the disease or for the hemophilia allele, the allele 5. Since the person 8 has the basal allele 5, since this one is coding for the disease. So this one is, for example, it says XH, while mother on the allele 3 on the allele 5, and the mother is 100% heterozygous. Why the fetus عنده بس allele 3 يعني ما عنده الفيتس the allele 8 so allele 5 sorry so the fetus is going to be normal. So specify starting from the analysis of the obtained O2 radiogram the real genotype of the mother and that of the fetus. The genotype of the mother is going to be what? يلا let's see. The genotype of the mother is under allele 3 or allele 5 and the allele 5 is the one coding for the disease. So what is the genotype of the mother, the real genotype? يعني دي new volunteers مين بقى في معي ما طلع Adil, what do you think? The mother will be a normal or abnormal if person 8 has only allele 5. So person 8 عنده بس allele 5 هيك. So person 8 عنده بس allele 5. Person mother عنده allele 3 وعنده allele 5 while fetus عنده بس allele 3. So what do you think about the uh, what do you think about the genotype of the mother? It's normal or affected? First, yes, Hadid, what do you think? The mother is normal or affected?
Normal.
Normal from the pedigree, very good. So نحن عرفنا person 8 عنده بس allele 5. So person 8 ليكون عنده بس allele 5 يعني عنده إياها XHY يعني allele 5 هو responsible for the hemophilia. However, mother عندها allele 3 و allele 5. So it will be what? It will be XM X while the fetus عنده بس allele 3 والفيتس طلع male عنده one copy. So sure it will be X and Y. Okay? So we estimate a 4% recombination between the polymorphic zone and the gene coding for factor 8. In this case, is the second test reliable for diagnosing the hemophilia in this fetus? No. Why? Because we have a possibility of the crossing over to occur here. So we have possibility of the crossing over. So let's review what we have solved before. This is the solution. So woman 6 is normal, but giving birth to a hemophilia a brother, since we can either be either homozygous XN or heterozygous XN XH and man X and Y. Why? Because it's normal and gives only one phenotype, one genotype. It can't be X and AY because if X and Y, XHY, sorry, because if XHY, it will be affected. Second, they said, can this help to identify the pedigree to determine? No. Why? Because the child to be born can be either a male or a female. It can either be a girl or a boy. For if a girl, this pedigree permit a sure diagnosis. Why? Because it will carry either XNXM or XNXH. But as a boy, either it can be XNY or XHY. So if this child is a female, so this pedigree will help assure diagnosis. Why? Because she will be normal, because her father can give her only XN, and regardless of her mother, either XNXM or XNXH, she would be normal. But if it was a male, the diagnosis is sure if the mother is homozygous. We can't the mother homozygous have the XNXM. But if the mother is heterozygous, can تعطيه either XM or can تعطيه XH. And in this case, it can be affected. Probability, we said that if the child was a girl, so the probability to be affected is approximately null, zero. While if the child was a boy, the phenotype depends on the allele provided by this mother. The possibility of the mother to be heterozygous is 1 over 2. So this, if she was heterozygous, there is possibility of 1 over 2 for giving her XH. And since we don't know the sex of the individual, so the probability to be a male or female is 1 over 2. So it will be 1 over 2 times 1 over 2 times 1 over 2. So it will be 1 over 8. Or we can solve it in another way. The probability for the mother to be heterozygous is 1 over 2. In this case, half the risk for the mother to be heterozygous. But in this case, the children to be affected, they have a risk of 1 over 4. So 1 over 4, the children will be affected or hemophilic. So the genetic risk will be 1 over 4 times 1 over 2. So it will be 1 over 8. For D, they ask for the pedigree. Is this pedigree allowing a precise or an accurate revealing that the boy or the girl is going to be normal or affected, or it helps to detect, to help the pedigree to diagnose the baby or the fetus? No. Why? Because the pedigree, as we show here, the pedigree is for a male. So the pedigree is for a male. Here is the problem. So if it's for a female, it's very easy. This will help us a lot. But this pedigree is this karyotype, sorry, is for a male. So this karyotype is for XY. And here's the problem. If it's XNY or XHY. And here's the problem. While if it's a male, a female, sorry, if it's a female, it can be XN, XH, or XN, XN. And this will be normal 100%. But it's a male, so here's the problem. So no, that this karyotype allow precise or reveal the phenotype of the individual. We said no. Why? Because the karyotype could be that is a male. So if it was a girl, the problem would have been solved. Part E. What did they say in part E? Specify starting from the analysis. Specify, so we have to justify. Here in this part, most of you, what did they do? They said mother has allele A, allele 3, and allele 5. Person 3 has allele 5 only, so it will be it will be, for example, XHY. And allele mother will be XNXH, and fetus will be XNY. Here, you won't get any of the mark. Why? Because you have to justify. You have to justify your choice and your answer, since the verb is specifying. So specify, starting from the analysis of the obtained radiogram, the real genotype, the mother and the fetus. So here, person 8 has only allele 5. Person 8 is hemophilic. So we can see that allele 5 is linked, is related with the allele H that codes for hemophilia. So here, the person 8 has only allele 5. So this allele is coding for hemophilia. So it's linked for this. While mother 6, she's normal, but it has the two alleles, allele 3 and allele 5 on the X chromosome. So since allele 5 is a link with allele H, and since mother 6 is normal, so it should carry the allele M also. So this allele and will be linked for the allele 3. So here it's healthy, but it's heterozygous, having the genotype XNXH, while the fetus has only one allele 3. So he received XN from his mother and is going to be boy, a male. So he received XN from his mother and Y from his father. So he will be normal, having genotype XNY. Here, to answer the question is with justification. Without justification, you will lose mostly all the grade. So you have to pay attention to this. Okay, moving now to part 4. We estimate that we have 4% recombination between the polymorphic zone and the gene coding for factor 8. In this case, is the second test, which is this test of the radiography, is reliable for diagnosing hemophilia in the fetus? Justify the answer. He said no. Why? Because there is a high chance of crossing over between the polymorphic zone and the gene. So the non-sister chromatin of the two homologous X chromosomes will exchange segments. So this will lead to the formation of X chromosome on which allele 5 is linked with the normal allele, and another X which will be linked with the hemophilic. Thus the fetus maybe will be hemophilic even if his autoradiogram shows the presence of the allele 3. So if you have crossing over, we have a high chance for this individual to be hemophilic. And here is the case of the crossing over, and we have to pay attention for this. Here, in this case, we determined and we solved this exercise. This exercise, we introduced pedigree, karyotype, and autoradiography and gel electrophoresis as well. So this is a overall and this total question, all the answers, all the possibilities, they are found here. Yesterday, we solved the question that includes these restriction sites, and we talk about the bands, how many bands do they have, and there are different bands also related to the pedigree. Before, we solved the karyotype related to the pedigree as well. So here, these will help you a lot in order to determine and to understand and to start solving. Solving exercises is your key. Without solving exercises and solving them orally, this is not the solution. And this is not the way how to solve genetic exercises or any other exercise in biology. You have to write and you have to solve and you have to follow these steps. You have to pay attention to the action verbs. You have to pay attention to the questions very well. You have to look at the pedigree. You have to start from the parents leading to the offspring. You have to pay attention to the karyotypes to detect the chromosomal abnormality. In this case, for example, we have Turner syndrome. For example, some cases we have pedigrees. If it's X-linked, Y-linked, if it's autosomal. I said yesterday, cystic fibrosis is one of the diseases that's always going to be autosomal. It's found on the chromosome number 7. Even though they ask you discuss logically the chromosomal localization, always it will be on the chromosome number 7. So it's autosomal. Always. Whenever you see cystic fibrosis, it's autosomal. All these questions we solved during this week, they are related to the official exams, and pay attention to these questions. Try to practice these questions. Try to solve them by your own because this will help you a lot during the exercises or during the quizzes or exams as well.